Hello, class. Today we're going to start with Case Study 2A Notes Part 4, which is going to be T-Practice Part 1, okay? Before we go on to the T-Practice, I want to kind of talk about where we left off last time solving this test statistic, okay? So this was the test statistic for Case Study 2A, and I wanted to go ahead and let you know, like, where did I get these numbers from, okay? So here was case question 2A, all right? It gave us the data. So we'd either have to calculate X bar and S by hand or use StatCrunch. I'm not going to be too worried about you being able to calculate it by hand. If you know how to calculate it by hand, that's great. I'm going to show you how to use StatCrunch. Okay, so here I have the data all listed into StatCrunch. Okay, how you get to StatCrunch is here is your Pearson homepage, and you have this little option over here off to the side, StatCrunch, and then you're going to click view the data sets from your textbook. And it'll default you to here are the data sets from your textbook, and here's a blank page. So I went ahead and already, typed in the data, double checked it. Okay, so what we're going to be doing is going to stat summary statistic columns. Okay, and then we're just going to select the column that we want the data on. Don't have to worry about any of the middle stuff, and just press compute. Okay. So that's where I got our standard deviation, S, of 3.64, okay, and where we got X bar, our sample mean, 12.44, okay? Now, the other thing that might be helpful is taking a look at the histogram. So I'm going to go to graph, and we'll go down to histogram. And same thing, I'm going to select the column that I want, and then I'm going to press compute. Okay, so here's a visual of what our histogram looks like. Okay, and so not super bell-shaped, but if we took a pencil and kind of curved it over this, we would have an approximately normal bell shape. We've got a little dip right here, a little slightly smaller dip right here, but other than that, we do have that slightly normal bell-shaped curve going on. Okay, so just to kind of share screens for a moment. Okay, what were the requirements for this test statistic? Okay, our data had to be approximately normally distributed. All right, that's approximately normally distributed. Okay, sigma is unknown and estimated with S. Okay, do we have a sample standard deviation? Yes, we do. 3.64 rounded up. Okay, so you see that's what I plugged in here for our standard deviation, and 12.44 is what we plugged in for X bar for the mean. Okay, be comfortable with being able to read this output and being able to assign any symbol or word to it. Okay. All right, so I want to take a moment to show you that. Okay, now let's go ahead and once we calculate a test statistic, that's when we're able to use our t-table to get a p-value, or more so, get a range on our p-value. With our t-table, we don't get exact p-values. We get, hey, our p-value is between this and between that, or bigger than that, or smaller than that. And that's really all we need to be able to make decisions, okay? So T-Practice Part 1 requirements, okay, what we're going to look at is I tell you for each of the following scenarios, calculate the p-value and state your decision based on alpha equals 0.05, okay? And all the information I give you is that it's right-tailed, our test statistic is approximately 1.55, and the null distribution is has a t distribution with 21 degrees of freedom. Okay, if the degrees of freedom are 21, the sample size is going to be, yes, 22. Okay, but 21 is what we need when we use our t-table and we go to degrees of freedom right here. Okay, so this is a right-tailed test. Okay, so right-tailed, what does that mean? Means we have this greater than sign going on in AJ. Okay, the test statistic is 1.55. So you're not calculating T. I'm not giving you X bar and S and the sample size. I'm just giving you T. Okay, so this is just strictly just really practice writing the p-value statement and actually getting a p-value from our t-table. Okay, so the first thing to always start with is the probability statement. So our p-value is going to be the probability of t being greater than or equal to 1.55. Okay, so the probability that t is greater than or equal to 1.55. Okay, and I didn't leave myself a lot of space, but I do want to go ahead and draw, what this is saying to us. Okay, so that means draw my distribution here at 0, and I'm up here at positive 1.55, and I want the area above it shaded. Okay, so I need to know that my degrees of freedom is 21, and I need to know this 1.55, and I'm going to go to my t-table. Okay, and my degrees of freedom was 21, so I'm going to zoom in a little bit and put 21 at the bottom of my screen. Okay, 21. And then I'm going to scan, starting at 21, I'm looking for the number 1.55. I'm going to stop right here because 1.55 would land right in between 1.49 and 1.62. So that makes, I can then trace up, and those are the two probabilities I want, 0.06 and 0.075. All right, so what does that mean? It means that, so the final answer here, because the question is asking us to calculate the p-value. Okay, so box in your answer for me. Calculate the p-value. Okay, now another way that you can write the p-value, because if you notice over here, I set the words p-value is equal to the probability that t is greater than or equal to 1.55. So since I started the problem with saying, hey, these two things are equal, that means I can write my answer either one of these ways, and it means the exact same thing. Okay, you can either say the word p-value after you define it, okay, or you can write the actual probability statement. Both of those are in this pink box are going to be the correct answer to calculate the p-value. Okay, and then from there, the next thing it asks us to do is state your decision based on alpha equals 0.05. So is our p-value smaller or larger than 0.05? Okay, well, something you can do, and I'm gonna try to use some different colors today, alpha equals 0.05. So what you can come in, and you can come in here and you can say, okay, 0.05 is smaller than 0.06, okay? I also could have written this as, hey, well, alpha is smaller than 0.06, okay? So our alpha is smaller, not our p-value. So that means our p-value is bigger. So what does that make our decision? Fail to reject HO, okay? And this is something where I do think it can be helpful to kind of, after you box in what your answer is, just place alpha. Alpha will either be on the left side or over here on the right side. And that's all you really need to help you make your decision. Okay, let's look at another. All right, this is a test that, again, is going to be right-tailed. The test statistic is approximately 4.1, and the null distribution is a t-distribution with 29 degrees of freedom. Okay, so first let's start with the probability statement. So it's going to be the probability of t being greater than or equal to, based off the definition of p-value, 4.1. Okay, the probability of observing the value of my statistic or more extreme if HO is true. Okay, and so that's what I have typed right here. All right, so now, okay, let's draw the picture. Okay, I'm gonna really encourage, let's draw the picture every time I'm drawn up here. Okay, so we're here at 0. All right, this is T 29 degrees of freedom. Okay, and I'm down here at 4.1. And it's right-tailed, so I want everything above 4.1. All right, so then we go to our t-table. Okay, maybe notice that, hey, this probability that the t-table gives us is greater than, so that makes it really easy when our test statistic is right-tailed like this, or our hypothesis is right-tailed like this. Okay, and so the degrees of freedom are 29. So let me just go ahead and clean this up a little. Okay, so degrees of freedom, let's zoom out a little, are at 29. Okay, and there's the top of our screen, our chart. Okay, so I'm going to start here at 29 and I'm going to scan across and I'm looking for the number 4.1. And it's not on the chart. Okay, it falls off the chart. So I have the number 4.1 floating out here somewhere. Okay, and so now what we usually do is we go to the top, but we're going to go to the top and we're going to be like, oh, there's no number there. Okay, but if we look along the top, so starting on this end, we notice 0.2, 0.15, 0.1, 0.07. Do you notice that these numbers are getting bigger or smaller? They're getting smaller. So by the time we get out here, I don't know exactly what number is going to go there. But based on this chart, I know this number, my probability that I'm looking for, is going to be smaller than 0.001. So when your number falls off the chart to the left, you're going to report that it's smaller than that smallest number on the chart. The p-value is less than 0.001. Or you can also write, your probability statement. The probability statement for our p-value, the probability that t is greater than or equal to 4.1, that is less than 0.001. Okay, so at any point, if you want to try one of these on your own and then pick back up with the video, you can kind of just pause me at the end of any one problem and kind of just give it a go, okay? I'm gonna go ahead and keep going through all these. Oh, last thing that we needed to do, we need to make a decision, okay? So our p-value is low. So again, if I box this in, like this is my p-value answer, either one of these, okay? And then alpha was set at 0.05. And so 0.05 is over here. 0.05 is bigger than our p-value. So if the p-value is low, what do? We reject HO and accept HA. All right. So next problem. Now we have a left-tailed test statistic, okay? I'm sorry, I keep saying that, left-tailed hypothesis. Our hypothesis is left-tailed. So when we go build our p-value statement, we're going to use a less than or equal sign. Our test statistic is -1, and our distribution is T4. Okay, so how are we going to write that probability statement? It's going to be the probability that T is less than or equal to -1. Okay, now our t-table doesn't give us less than or equal to, so we're going to use the idea of symmetry to help us out here. Okay, so if I stick with my colors, okay, this is the p-value statement. Okay, what's down here is just what we're going to be thinking about whenever we go to use our chart. Okay, so I want to zoom in a little bit and draw my picture of what's going on here. We're down here at -1, and I want everything that's less than -1. Okay, and I'm actually going to go ahead and shade this in with the pink because that's what our p-value is. Okay, remember, if we fold this distribution in half at the 0, then this shaded area pink is going to be the same as this dotted area of pink. Oops, and this is going to be positive down here. Okay, and so the dotted area, that's what the chart gives us, but then that is equivalent to the shaded region. Okay, well, there I got a little sneak peek of our answer. All right, so we're going to go to our T-table and our degrees of freedom. So again, let me just go ahead and take a moment, clean this up. Okay, our degrees of freedom for this problem is 4. Okay. So here we are at degrees of freedom 4, and we're going to be looking for the number +1. Again, that's because we're going to use this idea of symmetry and that this is giving us the greater than. So even though our test statistic is -1, we're going to look for the positive end. So we're looking for 1, and 1 is going to fall right between here, between 0.94 and 1.18. So then we go up to the top. Those are the two probabilities that we want. Okay, so again, being consistent with the colors here, this is our p-value that you would box in. Our p-value is between 0.15 and 0.2. Okay, and you could also write that with the probability statement, okay? Make a note that it's either or here, okay? You don't have to write them both ways. You can, that's absolutely fine. Okay, so p-value, is it high or low compared to alpha? Okay, alpha is 0.05. So 0.05 would go down here, okay? So the p-value is not low, so that makes our decision fail to reject HO. Okay. Okay, so now for these next ones, what we're gonna look at is in 1 through 3, I gave you the test statistic. There was no calculations. Now what we're going to do is we need to start with actually making the calculation, okay? So I give you the mean, the X bar, the S, the N, okay? So first thing to note, if your N is 15, what does that make your degrees of freedom equal? 14. N minus 1. So 14 is where we're going to have to go when we use the T-chart, okay? But we're not quite ready to go to the T-chart yet because first we need to make a calculation. All right, and so we're practicing with our T-test statistic. So for X bar, you're going to plug in X bar equals 2. For mu, you're going to plug in what you know from HO. HO, mu equals 15. And we're assuming HO to be true throughout the hypothesis test. Oops, I'm so sorry, not 15, 1.5. Okay, 1.5 is what you will plug in for the mean. Okay, S of 0.07, that's what you'll plug in down here for sample standard deviation. And then N of 15 is what you'll plug in the denominator, okay? So definitely take a moment, pause right here, type these numbers in your calculator and make sure that you get T equals 2.77. Okay, so T equals 2.77. That's our test statistic now, okay? So the same instructions still apply. You know, we're just writing our p-value statement, getting our p-value from the chart, making a decision, okay? So now that we have our test statistic, we're able to write our probability statement. So a p-value, probability statement is gonna be the probability that T is greater than or equal to 2.77. Okay, greater than or equal to 2.77. Let's go ahead now. Clean up my chart a little bit. My degrees of freedom for this problem is 14. So let's go to 14. We're looking for the number 2.77. So 2.7, oh, maybe right in here. Between 2.6 and 2.9. So then we go up and we say, hey, our p-value is between those two probabilities. So 0.005 and 0.01. Okay, and you could have also drawn a picture for this problem as well. Anytime before you go to the Z or the T table, you can draw a picture. Okay, this was T14. 0 is in the middle. And we were looking up here at 2.77. And then this shaded region is what's going to be our p-value down here. Okay. And so now that we have our p-value, we compare our p-value to alpha, and alpha is 0.05. So our probability for p-value is anywhere between 0.005 and 0.01. So that means 0.05 would go out here. Okay, so if the p-value is low, our decision is going to be reject HO and accept HA. All right, number 5. Ooh, new page, new page. Okay, so again, we're going to start with actually calculating our test statistics. So let's get some practice. What's that formula that we're starting with? Okay, go ahead, pause here, take some practice typing this into your calculator. And you should get t equals -1. Okay, so now we are going to look at the probability for p-value being the probability that t is less than or equal to -1. Okay, which again, we can use symmetry here. So if I want to draw my picture, oops, this is a little long. Zero down here at -1. Okay, this is my p-value. Okay, but what I have shaded in that like dark pink color, well, that's going to be the same as the area here. I'm going to try to write a positive sign, but we don't need to. This is 1. Okay, that's going to be the same as this shaded area up above. Okay, so then we're our degrees of freedom here. So n is 25, so degrees of freedom is 24. So now we're going to go down to 24 degrees of freedom. Okay, we're looking for the number +1 now, okay? And again, it's because we're using this idea of symmetry. The table doesn't give me less than values. It gives me upper tail values, greater than values. So looking for +1, and 1.00 is going to be before 1.0593. So we go up to the top, and then we see, oh, those are our two probabilities. So our p-value, again, keeping the colors, our p-value is between 0.15 and 0.2, okay? And if you compare that to alpha, alpha is gonna be down there because 0.05 is smaller than 0.15. So the p-value is not low. What does that make our decision? Fail to reject HO. Okay. So go ahead, take a moment, calculate this test statistic with T. And when you do that, you should get the number 5.27, okay? In this space up here, I'm gonna draw that. I've got 0 in the middle, We're way up here at 5.27, okay? And we want the area that's greater than 5.27, okay? So N is 10 degrees of freedom is gonna be 9. We're gonna go to our T-chart, okay? And we are looking for 9 degrees of freedom. And we're scanning for the number 5.27. It fell off the chart. It fell off the chart to the left. So what do we know about it? It's got to be smaller than this number right here. That's how we're going to write our p-value statement. Okay, our p-value is smaller than 0.001. Okay, p-value is smaller than 0.001. So if we come in and then we talk about alpha, well, alpha is going to be bigger. Ooh, not much better. There we go. Alpha is going to be bigger than 0.001. So our p-value is low. What do? We reject HO and accept HA. All right, well, thank you guys for tuning in to Case Study 2 Notes Part 4, okay? This was just strictly getting some practice with our p-value step.